In this video, we will be using the review packet second 6 weeks test number 2, but we'll be focusing on using our TI nspire calculator. TI nspire CX calculator tutorial. So you need your calculator plus this review packet. I'll begin by looking at problem number 5. Number 5 says, which mapping best describes the function f of x equals negative x plus 4? We know this we call function notation. F of x is simply another way to say y. We could rewrite this equation as y equals negative x plus 4. When the domain is this set here, we know domain is the input. In the input, we typically call the x. So they're giving us a set of x's. They're asking us for the corresponding f of x's. So I'm going to make a table. The input, the x, comes from this set. X is negative 1, 1, 2, and 3. We want to know what are the corresponding f of x's, the corresponding output y values. Well, our calculator can do this very quickly. Coming to from home screen, we'll select graph, choice B. Now I have a previous function in here. My function is written down here at the bottom. I want to delete that function. A couple ways I can do it. One is I can hit tab and it brings up where we can type in another function. This says F2. The second function, I could scroll in and I get to my F1, I could delete there. Likewise, I could hit menu, 1 for actions, 4 for delete all. Do I want to delete everything? Yes. So 2 different ways that I could delete that. Now I want to enter in this new function. F of x is negative x plus 4. Again, I first hit tab. 2 below escape is tab. It prompts us f1 of x. This just means the first equation. Keying in negative x plus 4. Negative below the 3. X at the bottom plus 4. This function is now typed here. I hit enter. We see here's the line graph. Notice the y-intercept is 4. Notice the line moves in a downward fashion because the slope here is negative 1. Slope is the coefficient of x. But what I'm interested in are some y values. Well, let's look at the table. Hit menu. Menu. 2 below on. 7 is table. Split screen table 1. Now I can simply find these values. I see that 1 pairs with 3. When x is 1, f of x is 3. 1 pairs with 3. 2 pairs with 2. 3 pairs with 1. In this case, we see as the x values increase, the y values, the f of x's decrease. That's because our slope is negative. What does negative 1 pair with? I can simply scroll up to find that. Negative 1 pairs with 5. So we have used the calculator to find our table. Now we can take the table and easily see which mapping pairs with that, which mapping is an equivalent statement, and that is C. Negative 1 pairs with 5, 1 pairs with 3, so forth. Alright, the next problem we will look at using our calculator is number 10. Essentially the same question. What is the range, that is the set of outputs, range is the y, when the domain is negative 3, negative 2, negative 1? Well, again, x and f of x. Domain is our x, these are our x's. Domain is the set of x's, so these values go in for x. -3, -2, -1. I want to know what the corresponding y's are. Again, I can enter this function in my calculator. Alright. I'm going to leave my table here and simply hit tab. Pardon me, let's remove the table to see what that looks like. Menu, 2 is table, 1 remove table. So now the table is gone. Again, I want to delete this function. I could hit menu, actions, 4 for delete all, or simply hit tab. It brings me the second function. I will mouse up, arrow up one time, and it brings me to the first one. So I will change this to -2x minus 4. -2 x subtract 4. Now hit enter. You see that the line has some similarities. It's moving down as well. The slope is still negative, but the y-intercept now is a -4. And you can see -1, -2, -3, -4. That's where the line crosses the x-axis. Alright, so now all we need are some table values. When these are the x's, what are the f of x's? Menu, 7 is table, split screen table, and here we are. -3 pairs with -2, -3 pairs with -2, -2 pairs with 0, and -1, pardon me, -3 paired with +2, I should say. -3 pairs with +2. -1 pairs with -2. Again, we'll see this phenomenon when x increases, y is decreasing because the slope is negative. So we simply want to select the answer that has a range of 2, 0, and -2. So number 10 we see is A. I'm going to show one of these by hand over here. We have f of x equals -2x minus 4. Let's examine when we substitute -1 in place of x. Naturally, we should show it going in both places. There's an x. So we make the statement f of -1, substituting in place of x, -1. -2. Instead of x, we substitute -1 minus 4. F of -1. -2 times -1 is a +2. +2 minus 4. Well, 2 minus 4 is -2. We say that f of -1 is equal to -2. This is exactly the same as saying, this is analogous to this point. Here we see -1 pairs with -2. When x is -1, the function value is -2. These two statements are the same. Right. That is problem number 10. Now on to problem number 12. 12 gives us the function f of x equals 3x squared minus 7. We're looking for f of -3. All I got to do is substitute -3 in there. I could again go to my my table, but since this is just one value, I'm going to do it using the scratch pad. Alright, so first I'll write out my statement, what I'm wanting to do. I'm substituting -3 in place of x, so f of -3 is equal to 3 instead of x, -3, quantity squared minus 7. Well, in my head, -3 squared is 9. 9 times 3 is 27. 27 minus 7 is 20. This should be 20. F of -3 equals 20. Let's use the calculator and see if we can evaluate to see that. That's 20 there. Alright, so simply evaluating the right expression. 3 open, negative 3, close, quantity squared, subtract 7, crossing our fingers, let this be 20. And it is. Alright. Again, f of negative 3 equals 20 is the same as saying when x is negative 3, y is 20. Okay. Problem number 14. 14 shows us this pairing. 1 goes to 3, 3 goes to 5, 4 goes to 6, 8 goes to 10, 9 goes to 11. Well, I hope you can certainly see that the difference here is 2 each time. To get from x to y, we're simply going to add 2. Therefore, the function needs to be a. Y is equal to x plus 2. In this case, we wouldn't employ the calculator at all, but what if it were a little more complex? Well, the calculator might be helpful. Here's how I could do this one. Coming back to my screen, I'm going to remove my table. 7 table, 2 remove table. Alright, I'm going to hit tab, scroll up to my first function, enter in x plus 2. X plus 2. In F2, I'll enter in x plus 5. Scrolling down, and you see how those two lines have been graphed. They're parallel because those two slopes are the same. They both have a slope of 1. One has a y-intercept of 2, the blue line. The other has a y-intercept of 5, the red line. Alright, now in F3 I'm entering 3x. What do we anticipate this line to look like? Well, the slope is greater. This new line should be steeper. And there we see it. The black line is steeper. It has a y-intercept of 0. One more function, F4. I'm going to enter in 4x, subtract 1. How does this line compare to the C one? Well, the slope is greater. The new line will be steeper, but the y-intercept will be smaller. And here you see the last line purple. It is indeed steeper than the black one. And you see the y-intercept is negative 1. Well, what we're interested in here is who has the table such that 1 pairs with 3, 3 pairs with 5, 4 with 6, 8 with 10, 9 with 11. Now I'm going to show you a new feature of the table that might even be more helpful. Instead of having a filled-in table, I can put in x values that I want only. I'm going to menu. Table is 7. Escape, pardon me. Table. Hit my split screen table. It brings my table up. Now I'm going to change the way the table looks. I'm going menu, table, number 2, edit table settings 5. Now you notice it says table start 0 and table step 1. That's fine for us, but what I'm interested in changing is the independent from auto. Remember, independent is the x value. I'm going to change it from auto to ask. Scrolling, go down to ask, hit OK, and then come down to OK at the bottom and hit enter. Now my table is blank. Now I can enter in any values I want for x. I'm going to show how I did that again. Once I'm on the table, I hit menu. Then at menu, I hit number 2 for table, and then edit table settings 5. And then I change the independent to ask because independent is the x. It's going to ask me for an x. I didn't change the dependent. Okay. Now I can scroll to my x and start entering in these x values I'm interested in only. 1, 3, 4, 8, and 9. You can see this would be very helpful if the numbers were very large or they were decimals. We wouldn't want to scroll to say 4,000, and this table couldn't show us 2.5. So this is very helpful, and in this case it's very helpful because now we can see only the y values we're interested in. We see 1 pairs with 3, 5, 6, 10, 8 goes to 10, and then lastly 9 goes to 11. So I can see that that is indeed our F1, which was x plus 2. which we knew in the beginning, but you can see how this table setting feature will be beneficial. That'll be all for this video, and I'll look at the rest of the problems in a second video tomorrow.